Hi, Algebra 2 students. Today you're going to learn another method to solve a quadratic equation. When we're solving this quadratic equation, we want to know what x values are going to make this equation equal to 0. So for the first step, you need to make sure when you are solving quadratic equations that they are equal to 0. And this quadratic equation is equal to 0, so we are okay to go on to our next step. The next step after that is to factor the function. Okay, I'm going to factor by grouping. So I'm going to look at this. I'm going to say my leading coefficient here is 1. I'm going to multiply that times the constant. That's 10. I need to think what times what multiplies to get 10 that adds to get my middle term. Well, my factor pairs of 10 are 1 and 10 or 2 and 5. And that is going to be 1 and 10. And now we want to make them both negative because two negatives together will give us a positive, and a negative 1 plus a negative 10 gives us negative 11. The next step when we are factoring by grouping is we want to write down this first term as is, x squared. We uncombine that middle term. We use what we got right here to uncombine that, so that's negative 1x minus 10x, and then we keep the constant, so plus 10 equals 0. To factor by grouping now, what we're going to do is we're going to look at these four terms as two separate groups. I like to put my template out like this. I look and see what is the GCF of this first group, and the GCF of this first group is an x. So I'm going to factor that out. When I factor that out, I'm left with x minus 1. And now here I have a negative 10x and a 10, and their GCF is a 10. And I'm actually going to pull out a negative 10 because this first term here in this group is negative. Whenever that happens, you want to pull out a negative number for that GCF. So I'm going to divide by negative 10 and divide by negative 10. That gives me x minus 1. Now I know I'm on the right track because this x minus 1 and x minus 1 match. I am now going to factor that out, and I have x minus 1. I write it once. That's gone now. And I write what I'm left over with, and that's x minus 10 equals 0. Okay, so now I have step 1, it's equal to 0. Step 2, we have just factored the function. Now step 3, we're going to set each factor equal to 0, and we're going to solve for x. So I have this factor right here. I'm going to take that factor. And now I'm taking this factor right here and setting it equal to 0. And now I'll solve for x for both of them. So I'm going to do a little mental math here. I know if I add 1 to both sides, I'm going to get x equals 1. And add 10 to both sides, I get x equals 10. Now I want to talk about why we set those factors equal to 0 real quickly. When I'm looking at this, okay, there's something called the zero product property. So let's talk about that first. If I have two factors, so I have a times b, okay, and it is set equal to 0, I know in order for this to be a true statement, either a has to be equal to 0 or b has to be equal to 0. So in this case, I have one factor here, x minus 1, times another factor here, x minus 10, is equal to 0. Either this factor has to be equal to 0, or this factor has to be equal to 0 in order to make it a true statement. All right, let's look at another one. Okay, so when we're looking at this next one here, this is what I call a jumping for joy problem. What's nice about this problem, step 1 and 2 are done. We've already have the function factored for us. So all we have to do with this one is we set x plus 7 equal to 0. And we set this factor equal to 0, 2x plus 3. When I solve for x here, I'm just going to subtract 7 to both sides. So that's x is equal to negative 7. On this one here, I'm going to show a little bit more work just because I have that 2 in front. So I'm going to subtract 3 first. I get 2x is equal to negative 3. Now I'm going to divide by 2 to both sides. And I get x is equal to negative 3 over 2. Okay, this one I have here because this is a little bit different than the first one and the second one. The first one was set equal to 0. The second one was set equal to 0 and already factored. This one is not set equal to 0 and it is not factored. So what we need to do here is we need to set this equal to 0 by subtracting 5. Okay, so that's what we need to make sure. If it's not set equal to 0, we need to get it so it's set equal to 0. Okay, so now I have 3r squared minus 16r minus 12 is equal to 0. I'm going to factor by grouping, so I'm going to take 3 times negative 12, and that gives me negative 36. I'm going to think what times what multiplies to get negative 36, that adds to get negative 16. If you're a little confused on what that might be, you want to think of all the factor pairs of negative 36. So how can I get to let's just think 36 in general to start off with. I could have 1 and 36. I could have 2 and 18. I could have 3 and 12. Or I could have 4 and 9. Okay, one of these factor pairs has to work in our little puzzle over here. And hopefully you're saying, okay, I can do it, make 2 and 18 work. If I take 2 times negative 18, that gives me negative 36. And then we have 2 plus negative 18. That gives me negative 16. So I'm going to go ahead now and I'm going to uncombine that middle term. I need to keep that first term. I uncombine this middle term. Plus 2r minus 18r minus 12. 3r, now I'm going to factor by grouping. 3r squared and 2r, and then negative 18r minus 12. 3r squared and 2r, I have an r in common. So what's left? Oops, sorry, my mouse is not working very well here. Okay, I'm left with a 3r plus 2. Okay, negative 18r and negative 12, what do they have in common? Their greatest common factor that we can factor out is a negative 6. Why do I want to do a negative 6? Because this first term here, starting us off in the group, is negative. So I need to divide out a negative. It's going to be a negative 6. We're left then with 3r plus 2. We now know that we've done it correct because these match. So we have 3r plus 2 and 3r plus 2. We write that once. And then we write our leftovers, r minus 6. What's our goal? Our goal is to set each factor equal to 0. So I have 3r plus 2 equals 0. And r minus 6 is equal to 0. I'm going to subtract 2 to both sides over here. That gives me 3r is equal to negative 2. I'm then going to divide by 3. And I get r is equal to negative 2/3. And then over here, I'm going to add 6 to both sides. So I get r is equal to 6. All right, let's move on to the last slide that I have for us today. I have 3 different problems here. Okay, so I have 16x squared equals 25, 5x squared is equal to 25x, and then 3x squared plus 33x plus 50 minus 2x squared minus 2x. Okay, let's get started with the first one here. 16x squared equals 25. Okay, so the first thing that you'll notice here, again, it is not equal to 0. So we need to do that by subtracting 25 to both sides. When I do that, I get 16x squared minus 25 is equal to 0. I'm going to look and I'm going to see, do I have anything in common? Can I pull a GCF out? I can't. I have two terms. They're being subtracted and they both are perfect squares. That's nice. Now we can use the difference of perfect squares. I do that by taking the square roots of both of them. And I write it twice. So the square root of 16x squared is 4x. I write that twice. The square root of 25 is 5. Set it equal to 0. And then I have that plus, difference of perfect squares, plus minus. Step 2 is to have them factored. We have factored them. And then step 3 is to set each factor equal to 0 and solve for x. I'm going to do that over here because I have a little more room. Oops, that one was the subtraction. Sorry, I made a mistake there. I went too fast. Okay, I'm going to use just a little bit of mental math here just so you're not watching the video forever. I'm going to subtract 5, so that's going to give me -5, and then I'm going to divide by 4. So x is going to be equal to -5 over 4. And then on this one over here, I'm going to add 5 and then divide by 4. That's going to give me x equals a +5 over 4. Another way you could write it is x is equal to plus or minus 5/4. Okay, we're done on that one. Let's look at the next one. On this one here, we have 5x squared is equal to 25x. Again, what I want to do is I want to subtract 25x because I want this side equal to 0. I get 5x squared minus 25x equals 0. Now, these are two terms that are being subtracted, but it is not difference of perfect squares. What can we do? Well, we can look for a GCF. Here, you always want to look for a GCF first when you're looking at things to see if you can factor anything out. I have 5x squared and I have -25x. The GCF of this is going to be 5x. I'm going to factor that out. I have 5x then times x. 5x squared divided by 5x is x minus 5. And I set that equal to 0. Now, that was step 2. It's factored. Now, step 3 is I'm going to set each factor equal to 0. Now, a common mistake is people forget about this one. This is a factor here, 5x. 5x is equal to 0. And then I have another factor here as well, x minus 5 is equal to 0. I'm going to divide by 5 to both sides here. I get x is equal to 0. I'm going to add 5. I get x is equal to 5. And we are good to go. The last problem I picked because, it's got a couple more terms over here just so it doesn't throw you a curveball when you see it on the homework. Again, we need to add this, so it's equal to 0, 2x squared, and add 2x. We bring it with the like term, so we're going to add 2x squared here, and we're going to add 2x here. That's going to give me 5x squared plus 35x plus 50 equals 0. I'm now going to look and I'm going to say, wow, 5, 35, and 50, they all have something in common. They have a 5 in common. So I'm going to take that GCF out. That leaves me with x squared plus 7x plus 10. And I'm going to set that equal to 0. Okay, so now I'm going to factor by grouping. I'm going to multiply that leading coefficient of 1 times 10. Right? Because that's a 1 right there. This 5 is GCF. I do not care about that right now. I need to think what times what multiplies to get 10 that adds to get 7. Hopefully you were thinking that's 5 and 2. So I take 5 times x squared. We're uncombining here, so plus 5x plus 2x plus 10. I'm going to factor this by grouping. Okay, this 5 just hangs on outside there. I take out an x here, so that's x times x plus 5. This is going to be a 2, so I take that 2 out there. 2 times x plus 5. I write my common ones, x plus 5. Those are gone. What am I left with? X plus 2. And I do have a 5 as a GCF out here. Now, why did I choose this problem? Because oftentimes people get messed up with this 5. This 5 doesn't have an x with it, so I cannot set 5 equal to 0. I can't solve for anything. That doesn't make sense. But I can set x plus 5 equal to 0. And I can set x plus 2 equal to 0. I'm going to use mental math here to subtract 5 to both sides, where I get x is equal to negative 5. And subtract 2 to both sides, and I get x is equal to negative 2. Sometimes this 5 throws people for a curveball. You can only set the GCF equal to, that you factored out, equal to 0 when there's an x like it in this second example on this page. Thanks so much, you guys, and have a wonderful day.